Since the polar coordinate system is just as valid a system as the Cartesian coordinate system, we should be able to take one point P and express it in both x, y, and r theta coordinates. Let me prove to you this is true with Desmos. So here's that point A we were working with in the last example, and I'm in the polar grid in Desmos. If I go up here to the little wrench and I switch my grid, I can see that point exists in the XY coordinate system as well, right? And there should be a way that I can convert and have either an XY representation of that point or an R theta representation of that point, and either one should be able to work. So we need that conversion factors, or well, not factors, but how we're going to convert. Okay, so if I have polar r cosine and theta, so if I have theta and r, then I can come up with x and I can come up with y. So x is equal to r cosine theta and y is equal to r sine theta. And boy, is that something you're going to need to know. If you're going on in Calc 3, I will tell you this gets used a lot. So in general, this is a polar to rectangular conversion. Now, that's not the only way it can be useful, but hypothetically, the way this is written is that you know r and theta and you're looking for x and y. It can be useful for the reverse as well, but we'll deal with that when the time comes. And then you can also see a couple other things. R squared is equal to x squared plus y squared, and the tangent of theta is equal to y over x. I actually want to talk about this just a little bit more, because that would mean that theta is equal to the arctangent of y over x, right? But that would also mean that we're restricted. So you're restricted in theta between negative pi over 2 and pi over 2, which is quadrants 4 and 1. Right? That's the way arctangent works. So this bit right here is really more, and that includes this bit too. So I'm just going to make a little note. This is more about, hey, if you know x and y, how can you get r and theta, right? So the way these are written is that it's assuming you know x and y, and then you can get r from this and you can get theta from that. Although theta, you can also think of it as the arctangent of y over x. Sorry, my y is a little weird there, so I'm going to try to rewrite that. There we go. So it's the arctangent of y over x, but that means you're restricted between quadrants 4 and quadrants 1. Now, that doesn't mean that's the only way you can do that, but that's it's the starter. So rectangular to polar. Because remember, of course, because of the periodicity, we could always add more angles, right? Add revolutions and such, but this will get you your starter angle. That's what I meant by that. All right, so let's go here. Let's see an example. So polar to rectangular conversion practice. So these are, because this is polar to rectangular, that implies that these are polar. So I want to take a polar point, which is r comma theta, and I want to convert it into a rectangular point, which is x comma y. So that means that for this point right here, r is equal to 4 and theta is equal to 5 pi. Okay, so if we look at the top bit right here, it says that if you know r and theta, then you can find x and y real easy. X is equal to r cosine theta. So that would be 4 times the cosine of 5 pi. Okay, well, it always helps to remind yourself of your unit circle. Let me draw a little unit circle here real quick. 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So 5 pi is over here. It's that angle right there. All right, so if 5 pi is over there, then that means that the cosine of it is negative 1. So this is really 4 times negative 1. Which would be negative 4. I'm just going to draw a little wavy line in the middle so that we can keep these two problems separate. All right, now what about y? Y is equal to r sine theta. So that would be 4 times the sine of 5 pi. Okay, but that's 4 times 0, which is 0. But look at the point. Right? It's over 4, right, on the fourth ring, and 5 pi, which I graphed in Desmos right here. So if you look at that point A, right there, that's a polar point, right? So it's over out to the fourth ring and around to 5 pi. But then think about what that would be in the rectangular coordinate system. It's negative 4, 0. That's what we just proved, right? So negative 4, 0, well, of course it is. I mean, look at it. I drew it right there, right? So that means that the point is negative 4, 0. All right, let's do it again. So this one's going to be a little bit more difficult. So I've got r is 1, theta is negative pi over 3. So let's think about where this would be for a second. I go out to the 1 ring and I go clockwise negative pi over 3. I'm going to be down here, right? So if you think about my unit circle, oh, that's a terrible unit circle. I apologize. So here, my axis is all off here. There we go. I should draw the circle first. It's my own fault. All right, so draw the circle, then draw the axes. So there you go, and I'm down here somewhere. It's actually a little bit further because I'm at negative pi over 3, not negative pi over 6. So I'm kind of down here. All right, so now I've just made a big mess out of it, but there you go. It's right there. Okay, so if I want the x, I want x to be 1 times the cosine of negative pi over 3. And I want y to be 1 times the sine of negative pi over 3. And luckily for me, we all memorized all of that stuff with our unit circle back in pre-calc. But I was going to show you the point. So I'll turn off this point, turn on that point. See, there it is, right there. Right, it's on the 1 ring, and it's down at negative pi over 3. Okay, but we remember the point that has on the unit circle. So it would be a half and negative square root of 3 over 2. So that's what I would use. So I would say it's the cosine of negative pi over 3 would be the x value, which is a half. And the y value is negative square root of 3 over 2. Right? So I would argue that that point is a half negative square root of 3 over 2. Okay, so for both of these, I'm using that x is r cosine theta, y equals r sine theta. So going from polar to rectangular, not so bad, right? As long as you know your unit circle, not too terrible. All right, now it gets tricky. Let's go the other way. Let's take the point 2, 2. So let me show you this on Desmos really quickly. So I'm going to take the point 2, 2, which is over here. And let me change my grid so you can see it. There it is, 2, 2. And I want to find a way to express it with 4 different possibilities in this grid system. Fun, huh? Okay, so let's go back, and I'm going to draw that picture really quickly. And I'm going to have over 2, up 2. So it's right there. There's my point. I'm just going to call it P. All right, now I have to figure out how to get there. Rather than going over to up to, I have to figure out how to get there with angles and with a ray from this positive polar axis, because the positive polar axis is out here, right there, and I want to swing up to that. So I want to go out a certain value and then swing up. Well, the first thing I need to figure out is how far out do I need to go, right? I need to know this distance from the origin out to P, which is what R is. Right? Because then I'll know what ring to go out to on my circles, my concentric circles, a.k.a. the polar grid, and I'll be able to swing around. So I need to find that value. Okay, well, what they're telling us up above is that you can make a little triangle. You can say, okay, look, if P is here and O is here, I don't want to do it on the grid. I want to do it over here because the grid will get too confusing. If this is 2 and this is 2 and this is R right here, are you thinking what I'm thinking? Because I'm thinking the Pythagorean theorem. X squared plus y squared equals r squared. See it now? Right? We've got this little drawing of it right here as well. But you can see it. 2 squared plus 2 squared will get us r squared. So r squared is equal to x squared plus y squared. So r squared is equal to 2 squared plus 2 squared, which is 8. So r is equal to the square root of 8, which is 2 square root of 2. There's our r. Now we know. We know that r is 2 square root of 2. Lovely. All right, so that's not so bad. And no, the r is not bad. It's the angle. The angle is going to be one less fun. Okay, so for the angle, I need to know that the tangent of theta, because the angle's right here. So if I say that's theta, at least my basic angle, I called it my base angle, or my beginning angle that I'm going to work with. Right, my base theta is going to be the arctangent of y over x, right? There's a little triangle in here, right? So theta is right here, and the arctangent of theta, let me put it this way, the tangent of theta is y over x. So that means that the tangent of theta is 2 over 2, which is 1. So if the tangent of theta is 1, that means theta is the arctangent of 1. So you have to think about your unit circle and think about what angle you know has a tangent that's equal to 1. Okay, so on the unit circle, what angle has a tangent equal to 1? Well, it would be the angle that has the over and the up equal to each other for our triangle, which is pi over 4, right? Because it has to be between negative pi over 2 and pi over 2. Right, it has to be in that, here, I'll draw you a little unit circle. Oh, I did it again. Here's the circle. Terrible. It's right here, right? It's got to be over there, right? So because it has to go from negative pi over 2 to pi over 2, that's the only places you're allowed to look. And quadrant 4 would have negative tangents. Quadrant 1 is going to have positive tangents, and it has to be that they're the same. So it's pi over 4. That's the angle. Wonderful. Okay, so we have 1 coordinates right there. So we have 2 square root of 2 pi over 4. There's one of them. No problem. But they want 4 different representations. Look, 4 of them. Okay, so that's using the fact that we know that we can get to this angle a couple of different ways. So you can go out to the 2 square root of 2 and then up pi over 4. No problem. All right, so pi over 4 is right here. Swinging over, right? There's your pi over 4. Well, how else could we get there? Well, okay, so we could go the other way, right, and swing backwards, right? So instead of going out 2 square root of 2 and up pi over 4, right, counterclockwise, we can go clockwise, right, and swing around this way. That would get us 2 square root of 2. That looks weird. Sorry. It's the end of the paper, so it's being weird with me here. All right, so 2 square root of 2, comma, and that angle would be negative 7 pi over 4, right? Because together they make 8 pi over 4. Together they have the full circle. So negative 7 pi over 4 would be that angle. I guess if I'm going to keep this color-coded, I'll do blue on this one so you can keep them straight. All right, so there's another one. But of course, we don't have to do positive r. We could do negative r as well. So if I went negative 2 square root of 2, okay, that means I start over here instead. So I start over on the left side, and all I have to do is get this little bit from here over, and that's all. Okay, so that would be 3 pi over 4, but it's clockwise, so it's negative 3 pi over 4, right? Because together they make pi. 180 degrees is pi. So if this is pi over 4, that little bit, then this has to be 3 pi over 4, because together they make the top half of the circle, right? So that's negative 3 pi over 4. It's negative because you're going clockwise. But of course, if you can go clockwise, then you can go counterclockwise because there's one more. This will get us our 4 representations. I'm running out of colors. I'll go yellow. I'll go purple. Yellow. Let's go yellow. So start at that same spot, but go the other way. Right? I realize it's not circular, but bear with me here. So, and I got to keep going and get that bit. So I got to get a pi plus a pi over 4. So that's 5 pi over 4, right? So 4 over 4 plus 1 more over 4 makes 5 pi over 4. There, now I have 4 representations.